What is up, guys? Welcome back to Vanover Customs. In today's video, we're going to be making some line boring alignment cones. We have this nice 4-inch log of steel in front of us that we're going to be making those out of. Let me bring you in closer and talk about the details of how we're going to get it done. Now, a job like this is relatively simple, but there are two main areas where you got to be a little bit careful or strategic, so that way we don't have any issues. The first one is the inner bore of these cones. Now, this is a 40 millimeter bore, and instead of just go off of 40 millimeters, what I did is I had the customer bring the bar by and I took a measurement with the micrometer to make sure we were going to get a proper fit. We don't want the fit too tight. If it's tight, he won't be able to get it on and off the bar freely, and if it's too loose, it's just going to be sloppy. So we really want to dial in that fit and make sure it's going to be proper. The second thing is when you're cutting the cones, you're going to need to do that on the compound, and just with work holding, it's a little bit tricky. If you kind of cut this off to conserve material, that's good for conserving material, but it's going to be bad for work holding. You're going to pretty much have nowhere to grab it because the taper comes all the way to the end. If we cut off a larger section of material, that's going to be excellent for work holding, but it's going to create a lot of waste. And this being a 4-inch material, it's not something that I want to readily waste. So the way we're going to get around that is we're actually going to take a large DOM piece of pipe and we're going to cut this off, allowing very minimal waste so we can save as much of this for future projects. And we're going to weld this in the center with multiple passes. That way we have something to clamp onto. And the reason why I think this technique is going to work out really well is it's going to allow us to do as many of the operations in one setup as possible. And that's something that's really, really important when we're talking about concentricity and making sure everything lines up. So I thought about it in a bunch of different ways. Most people that make these just kind of chuck up on the end, and that does work. But I think this will kind of give us the best of all the worlds. So the first step is to go over the bandsaw and just kind of get this cut off into 2 discs. And then the next step will be to go ahead and get this guy welded on and chucked up in the lathe. we went ahead and finished out that bore, and I tried to show you some metrology shots and kind of how I'm doing this with the snap gauges. I know a lot of people say that snap gauges aren't that accurate, and that's true and false. They have a feel to them, and so if you don't know how to use them or you're not comfortable, they are going to be inaccurate. If you know how to use them, they can be accurate enough for this type of work, and they're plenty accurate for that, but you just gotta have that feel. So the other benefit of a snap gauge, someone will say, whip out the bore gauge, or use an internal set of calipers. Internal hole shot mics are extremely expensive, and they cover a very small range, and bore mic is a great tool, but to set it up takes some time, and if you're changing sizes, it's very cumbersome. So bore mics work really good, or bore gauge rather, if we're trying to get 100% absolute perfection. But to be honest, if this was a thousandths in either direction, it would be fine. Now I'm shooting for within 2/10 of my target dimension, and the snap gauges are able to do that, at least for me. So not only are they quick, as the sizes move up as I'm boring, I can check them. Whereas if I had a hole shot gauge or a hole set gauge, I'd have to have all the sizes. And if I had a bore gauge, I'd have to be swapping out the tips and setting them to a master, and it's just not practical. So this works for me, and I'm able to get good results. So right now, I think you've seen in that last clip, one of the measurements was 134 or 133 and 9/10, and I'm shooting for 134 and 2/10. So I'm a little small, but that's better. I don't want to even take a spring pass at this point to try to get 2/10 out of there. If I need to, and he wants them a little looser, I can just kind of hit him with the flap wheel when he's here and take out 2/10 real quick. So here's a test piece that I made, and this piece, I didn't put a label on it, but it's about 1/10 smaller than his boring bar. And you can see it's a tight fit going in. And there you go, pulling out, probably has a little bit of air suction, stuck on the inside, there we go. You can kind of see, can't really hear it, but there's a little bit of air suction, not quite a shock fit, but it's a very close fit. So if this was 1/10 bigger, which is what his boring bar is, it probably would be like an air shock fit, which is probably too tight, to be honest. But I'd rather try to take a 1/10 or 2 out when he gets here with a flapper wheel than overshoot this and blow the part. So yeah, happy with that. We're going to come in here and cut the taper next and go from there. All right, guys, we went ahead and completed this project. I made a second one off camera. Everything was the same as the first, so there's no need to repeat that. And we have both parts over here at the bench. Now, overall, I am extremely satisfied with the result. As a machinist, you're always learning and growing, and I have a lot of mistakes ahead of me. But in this specific project, I feel like I was able to show a lot of the things that I've learned in the past couple of years and get a really good result, something that I'm personally proud of, which is excellent. So let's talk about the parts. Let me bring you in closer. Let's talk about the dimensions and do a little bit of metrology just to kind of show you where we're at measuring wise with the actual parts. All right, we're going to measure these in real time, so just to show you how long it takes and to show you where we're at. It may be a little difficult to see the screen, so I'll kind of call it out, but you should be able to see it mostly. And when I'm measuring these, I want to come in at an angle, and I like to get a certain feel when I'm pulling these out. And I like to do 3 measurements per one, ideally, but we'll see where we're at. I usually stand in front of it, so I'm struggling a little bit, but so I can't see the anvil, so. Okay, I'm getting 395 on that. Let me just reset this so it wasn't squared up fully. All right, 740, 7539. All right, so looks like we're about a 1/10 over on that measurement, or I'm sorry, a thousandths. Let me see if I can kind of get in here. Usually I stand where you're at, where the camera's at, and I get a little better reading. Okay, so 1.2 thousandths over where I wanted to be, or actually, I'm sorry, that would be 1.1 thousandths oversized from his bar, roughly. Let me just take a third measurement. And the measurements are also going to vary a little bit depending on where I take it in the bore. And we're working to a really tight tolerance here, so I'm sure it'll vary, a couple tenths. Yep, so 1.57390. So it's 3/10 narrower up here than it is down there, which is totally fine. So on the low end, we're 8/10 oversized, and on the high end, we're 1.1 thousandths, or 1/1000 and 1/10 oversized. And again, I said I wanted to be between 0.5 and 1/1000. So we're just past what I wanted, but just because I wanted it doesn't mean it makes sense. I'd rather have this just a tad on the looser side than on the tighter side, and specifically up here, it's a little bit smaller, so that would put us, 6, 7, 8/10 oversized. Way fine. So we're going to move on to the next one. And to me, consistency is a little bit more important than the actual measurement. That way they both feel the same, but again, we're working to a really, really small number here, so I'm just being real with you guys about how this turned out, good, bad, or indifferent. Okay, I'm getting 738. I'm just going to get rid of the 0.5 because we know about that. So 7/10 on that measurement oversize. And that upper measurement was with 1/10 of that other one. That is way good. I'm actually surprised. It shouldn't. I'm not that good, guys. I worked really hard to get these right, but they don't need to be. I'm just practicing more or less. And at the bottom of the bore, .390, so that's actually reading the same measurement, which is fine. I mean, we're talking 2 or 3 tenths here. So just take another measurement at the bottom. And I'm only showing you like 1 or 2. Usually I'll synthesize all 3. I got these to where they were close enough and I was happy with them after 2 or 3 measurements. So I'm just kind of not trying to waste too much time here. Okay, so that one's measuring 743, 742. So that's actually measuring almost identical to this. So at the end of the day, extremely happy with the bores. We are where I want to be, and these are within 2, maybe 3 tenths of being identical, which is way good for what we're doing. So that's the bore measurement. All right, I don't know if it's going to be the best for you to see this gauge, so I'll kind of read it out. But let's just set this one to 0. I've already set up the gauge, so we got about 15 thousandths of movement either way. And again, you know, I think this gauge is pretty sensitive, so I'm not overly worried about this, but we'll just see how off. Hopefully this one isn't lower or higher over 15 thousandths, but we'll see. So now we'll move the gauge, so we're 0-ish. We'll set this bad boy on there, and we will scan over. There's no way that's 0. There's no way. I don't believe it. There we go. I was going to say, not that good, guys. Okay, make sure that's seated. Make sure that's seated. Okay, great. This is great. So I'll double check off camera, but 1, 2 and 9 tenths, 2 and 9 tenths thousandths less on this one. Amazing. Completely unnecessary, but what that tells me is these two are the same in this dimension right here, which is great, within 2 and 9 tenths. Honestly, the only dimension that wasn't perfect was the width here, and this is why I'm showing it to you. I'm being honest. I had them both within 4 tenths on the width, and then I actually chucked this up in a expanding mandrel, which I've never used before, and tried to clean up this chamfer because it wasn't perfect. And in doing that, I lost that about 20 thousandths. But before I had them within, a couple tenths. But it doesn't matter. I'd rather, this one was a little on the sharper side before I adjusted them. So they were measuring the same, but visually it was pretty obvious. And so I figured it was going to be more important to make these feel better when you handle them and make them look identical than really focus. And I didn't even occur to me that when I adjusted this one, it was going to lose, 20 thousandths or 20-something thousandths. So, but at the end of the day, very, very happy with where these turned out. The dimensions that matter are way good, and everything else is surprisingly good. And again, these are just some beater line boring cones, so they'll be 100% fine. Well, guys, the cones are done. We measured them. I'm happy with where they're at. Time to call the customer and bring them over. I'll have them bring the bar. We'll test fit them. If there's any issues, could be a little tight, I'll hit them with the flap wheel to get them exactly where we want. But aside from that, they're done. I'm happy with them, and I know he is going to be happy with them. If you guys enjoyed this video, please let me know down in the comments. Like, comment, and subscribe, and we'll see you in the next one.